Hey guys, so today we're going to look at a little bit more at the graphs of our logarithmic functions. Specifically, we're going to start looking at transformations of logarithmic functions. Now, when you're going through the next few videos, you should have already had a bit of a review on what our different types of transformations are because we've already looked at exponential graphs, but we're also going to break those down again here. So the learning target we're going to work on is I can identify transformations of functions, given the graph, the equation, or the graph. So let's talk about our translations of functions. That's one of the types of um, transformations that can happen with our logarithmic functions. So translation is when we slide or we move a shape. We don't change the shape, we're just moving it. So it might look like the shape of the graph changes, but it's actually not. It's really just that we're looking at a different portion of it because we just moved it over to the side. So think about it as if you pushed a chair away from you, you might see it from a slightly different perspective than when you first were looking at it, but you didn't actually change the shape of the chair. This is going to happen when we're adding or subtracting with a parent function. We have two types of translations. We have our vertical translations moving up and down, and our horizontal translations moving left and right. And so our translations do move all of the points of the graph, which means this is going to change some of our characteristics of the functions. And it's really going to depend on what the translation was to change what those characteristics were. So let's start with our vertical translations. So a vertical translation in terms of the equation is going to look like f of x equals log base b of x plus c, where that plus c is outside of the logarithm. So that's going to shift or move the graph upward c units. So what does that actually look like? Well, here the red graph in this graph is log base 2 of x. So it's the parent function for log base 2. And then the blue graph is log base 2 of x plus 2. So what this does is you'll notice the green points, the black points, and the purple points each move up 2 units. So this graph from f of x to g of x translates up 2 units. Let's see how this actually changes the characteristics. So what happens with the characteristics of this function? Well, the domain is still from 0 to infinity. There's still a vertical asymptote at x equals 0. The range is still from negative infinity to positive infinity, just like with the regular logarithmic functions. One thing that changes is the x-intercept. So the x-intercept of the blue graph, instead of being at 1, 0, is at 1/4, 0. And I know that because I looked it up on my graph in Desmos. And then the end behavior is the same. So as x approaches positive infinity to the right, f of x is going up forever. And as x approaches 0 to the left, because remember it can't pass 0, there's a vertical asymptote there, f of x is going down forever to a negative infinity. So looking at our other vertical translation, if I have log base b of x minus c, that's going to move my function down c units. So again, looking at a graph, the red graph again is log base 2 of x, and now my blue graph is log base 2 of x minus 2. So you'll notice that each of those points moves down 2 units, and we could continue in every little point in here, every single point moves down 2 units. So it translates down. So what about the characteristics this time? Well, the domain is the same, the vertical asymptote is the same at x equals 0, the range is still the same from negative infinity to positive infinity. The x-intercept again changes to 2, 4, 0. Again, I know that because I know what it changed to because I looked at my the point on Desmos. And the end behavior stays the same. So for vertical translations, in terms of the characteristics that we've talked about, the x-intercept changes, but everything else stays the same. Let's think about horizontal translations. So horizontal being left and right. So for a horizontal translation, that notice now instead of just having x plus c, that x plus c is in parentheses. So that tells you that the plus c is inside of the logarithm. So if I have log base b of x plus c, that is going to shift the graph c units to the left, and it is going to change my vertical asymptote. So I will now have a vertical asymptote at x equals negative c. So here, if I have my graph from Desmos, again, the red is log base 2 of x. It's going to be that every single time. My red now is log base 2 of x plus 2. Notice the plus 2 this time is inside, and each of those points is moving to the left 2 units. So this translates left 2 units. So what does this do to our characteristics, our features of this function? Well, now the domain, instead of being from 0 to infinity, it goes from negative 2 to infinity. So that did change our domain. It also changes our vertical asymptote. So as it's set up here, the vertical asymptote is x equals negative c. So since we have that 2 there, our vertical asymptote is at x equals negative 2. The range stays the same from negative infinity to positive infinity, but just like before, our x-intercept changes from from 1, 0 to negative 1, 0. And our end behavior also is going to change. So our end behavior is going, as x goes to the right, we're still going to a positive infinity, but as x goes to our left, it's stopping at negative 2 instead of at 0 this time. So we would say here as x goes to negative 2, f of x is going to negative infinity. Let's look at the other horizontal translation here. So now if we're subtracting, that's going to move us, if we're subtracting c inside, that's going to shift the graph to the right c units, and we'll have our vertical asymptote at wherever c is. So if we look here, I have my log base 2 of x being my red graph, log base 2 of x minus 2 being my blue graph. Notice that each of those points moves to the right 2 units. So this was translated right 2 units. So what about those characteristics? So again, this changes our domain. Instead of our domain being from 0 to infinity, our domain is from 2 to infinity. We also have a vertical asymptote at x equals 2. So notice that from the domain, we get that vertical asymptote. Range stays the same from negative infinity to positive infinity, but we do have a new x-intercept at 3, 0. And my end behavior, my right end behavior stays the same for that as we move to the right forever, f of x goes to positive infinity. And as we move to the left, we can only get to an x of 2. We can't go further left than that 2. So f of x is going to a negative infinity. So when you're thinking about your end behavior, just to remind you, notice here that those 2 pieces of my end behavior, the left and the right, those actually come from your domain here. And then your, in this case at least, your y values come partially from your range. That won't happen every time, but it happens to be with this type of function.